Okay, let's move on. So now that we've completed lines, let's move on to functions. So what is a function? There's multiple definitions of functions. Here's a couple of discussions for you. So it says that a function is a relationship between two variables such that each value of the independent variable there corresponds exactly one value of the dependent variable. Okay, so what does this mean? This means each x, the input variable, has only one y. That's what makes something a function. Each input has only one output. Okay? It says a function is a rule that assigns to each element in a set A one and only one element in the set B. So what I like to think of is a function as a machine. You take something from what's called the domain. The domain is the set of inputs. Okay, so we take our values from our domain, usually that's our x values, and we throw it into the machine. The machine has a rule. For instance, let me make up a rule. What if I said f of x equals 2x plus 3? Let's say that's our rule here, okay? And then the machine takes the x value, does something to it, and spits it out into what's called the range. The range is the set of y values. So here we're saying x is our input, y is our output. X would be our independent variable, y would be our dependent variable. You can never get a y without having an x first. So for instance, looking at the notation, if I said, what is f of 3? What is f of 3? What that means is take the number 3 and throw it into the machine. So if I took the number 3 and I threw it into my machine's rule was 2x plus 3. So that would be 2 times, well, plug in that x value as a 3 plus 3. 2 times 3 is 6. 6 plus 3 is 9. So what's happened? We threw a 3 into the machine and a 9 came out of the machine. When you see this notation, f of 3, what that means is throw a 3 into the machine, and what they want to know is what comes out of the machine. So f of 3 is 9. When you plug a 3 in, you get a 9 out. Okay? Anything you plug in, again, is called the domain. Anything that comes out is called the range. So it says, decide whether a relationship between two variables is a function. So this is where you have to understand the key part of the definition of a function. Each x can have only one y value. Let me go back to this picture right here. Imagine if we threw in the number 3 and we got both a 9 and something like a 13. This would be 2 y values for an x value. That means it is not a function. Each x value can only have one y value, so we could only have one number come out. If you look at this picture over here, if you see x, it gets mapped by a function to some y value here. So here's my function f of x, and this right here is really a y value. So that's how you see it. When we're writing ordered pairs, we look at a point like 2, 3. What that means is 2 went into the machine, 3 came out of the machine. So this would be your 2, and this would be your 3 in this case, okay? What you can't have happen with a function is something like this, where here's the number 5. So this would show that 2 gets mapped to 3, and 2 also gets mapped to 5. This is not a function. You couldn't do this because you have an x value with more than one y value. So to remain a function, each x can only have one y. So with that in mind, let's look at example 5. It says deciding whether equations are functions or not. Decide whether the equations defines y as a function of x, yes or no. So here it's saying specifically, can y be your dependent variable? Well, how do you know if an equation is a function or not? Well, try solving for y. That's a nice hint. So if I subtract x from both sides on this first one, I have x minus y equals 1. I'm going to subtract x from both sides. I have negative y equals, well, it would be negative x plus 1 if I write it in proper order. Then I could divide everything or multiply everything by negative 1. Make sure you do it to every single term. And I would have a y equals, well, that would be a positive x minus 1. Notice I was able to solve for y. If I plug in an x value, I would have a single y value. So yes, this is a function. Let's try the exact same thing on the next problem, part B. I have x squared plus y squared equals 4. Again, what happens if I try solving for y here? Well, I'd subtract x squared from both sides. When I do that, I'd have y squared equals negative x squared plus 4. And then if I wanted to solve for y, the next step would be take the square root of both sides. But if you watched my algebra review, then it would be a plus or minus as well. Okay? Anytime you take the square root of a square, you have to remember there's two potential answers, a positive version and a negative version. So I would have y equals plus or minus the square root of negative x squared plus 4. I know that looks nasty, but I want you to think about this, okay? So what would happen if we plugged in an x value? If we plugged in an x value, how many y values would we have? Well, because we have this plus and minus out in front, just for plugging in one x value, I'd actually have two different y values. Sometimes it would even be undefined, but there would be times when I'd have two separate individual y values. For instance, if I plugged in x equals 0, 0 squared would be 0, negative 0 is still 0, plus 4, so that would be 4. So my y values would be plus and minus the square root of 4, which would be plus and minus 2. So here's an x value of 0 with two y values, 2 and negative 2. That means this is not a function. Okay, so what's a hint? Here's a hint for you. If you're trying to find out if y is a function of x, the easiest thing to do is look at your y term. If it's just y by itself, almost guaranteed it is a function. But if it's something like y squared, remember if you solved for it, you would have to take the square root and you would have plus or minus. Guaranteed you would have plus or minus on both sides. Okay? So if you had plus or minus, that would be two y values, which means it's not a function. So anytime you have y squared, y cubed, y to the fourth, anything like that, you most likely are not a function. So that makes it easy looking at the next one. If I see on C, I see a y squared term, easy enough for me to discern that this cannot be a function, because if I were to do this, I would have a plus or minus. So I'm going to go ahead and write no here. Okay, let's look at D here. What happens if your x is squared? That doesn't matter. All you really care about is your y squared, yes or no? My y is linear. It's just to the first power. So yes, this could be a function. Again, here I could solve for y. I would subtract x squared from both sides. I would divide by negative 1 or multiply by negative 1. That's no problem. But here it doesn't matter because each x value would have only one y value. Okay, so that's what I'm looking for there. That's algebraically. How do you know if something's a function? Well, there's another way to do it graphically. Remember, if I wanted to graph the line x equals 3, so imagine graphing the line x equals 3, x equals 3, the x value always stays the same, the y value changes, so that is a vertical line. So imagine x equals 3. And the idea with a function is each x value can only have one y value. So imagine that vertical line there. What we're saying is that vertical line can touch the graph at most once. If there's ever a point, like you see on this next one, imagine this was x equals 5, do you see that there's 2 points where this vertical line touches the graph? That means for the x value 5, there's actually two y values that work. In this case, C and B. Y equals C and Y equals B are the two y values in this second picture. Okay, so that means an x value has more than one y value, which means it's not a function. So if you ever see a vertical line, the vertical line test is just take a vertical line, go from the left to the right. If any vertical line ever touches it more than once, it's not a function. And if every vertical line touches it at most once, it is a function. So that's what the vertical line test is. If it touches it 0 or 1 times everywhere, then it's a function. If it touches it more than once anywhere, then it is not a function.